We're doing some renovations on our CNC router here, and we have a few examples of different threads. Over here we have an Acme thread, and then down here on the x-axis looks like this is a ball thread, which have much different profiles in their teeth. I also have a standard machine thread right here. This is what you would see on most bolts and screws, and the profile of the threads is the same as on this thread gauge. All of these teeth are 60-degree angles, so these would match into here. I think that this might be slightly off, but that's the same profile as a standard thread, a 60-degree triangle. You'll notice on both of these threads, the Acme and the ball thread, it's not even a triangle, so it's not like a standard machine thread. This is actually the cross section, would, instead of being a triangle, is a trapezoid on here. Typically, Acme threads have less backlash, and so they're used often on pieces like this, where you have rotation converting into translation. And this is the z-axis right here. I can't notice a lot of backlash on this. It feels really good, although we could put an indicator on it to actually detect exactly how much backlash we have. And then even better than an Acme thread is what we have here, which is a ball thread. You can see that the profile isn't a trapezoid or a triangle. It's actually a circle, a half a circle right there. And normally, for a bolt like this, you would have the nut go right onto the threads, and same with the Acme. There would be an internal thread that this would go into. The ball thread works differently though. There's not direct contact between this piece and our thread. There's actually a bunch of little ball bearings that mesh between the spherical profile here and some of the design inside of this block right here. So it acts sort of like a ball bearing, like a rotary bearing, except that the tracks are helical. So as you spin the bearing, we end up with translational motion as well. The backlash on a ball thread, if they're made right, you can get them just about zero. And that's why CNC machines often use ball threads, whereas manual machines, you'll see more Acme threads or standard machine threads, which carry a little bit more backlash with them. So ball threads are probably the best you can get in terms of backlash, and they work by, instead of having mating components directly, they have the ball bearings in between, and that takes up the rest of the slop between your male and female surfaces. This is a big ball bearing. It doesn't have its inner race, but this is essentially how they work. There's all these spheres that make contact with the outer race, and then the inner race would go right up against the inner spheres. And so you don't have any wobble at all because they're touching. Whenever you have a thread, like a normal thread, the surfaces can't touch perfectly because they would seize. There has to be a little bit of a gap so that they can move around each other. But the advantage of having these balls around here are that because they roll instead of slide, that allows you to have a contacting surface rather than a surface that needs clearance in order to move. And that's the same thing that happens here. We have, obviously they'd be much smaller, but they would mesh in the profile of the tooth, and then they come up around here in this sort of tube looking thing. They kind of cycle through there as it rolls along, and it has a perfect contacting surface rather than a clearance surface. So those are some of the major differences between standard Acme and ball threads. We see a few of these different types all in the same machine, but the ball threads are definitely the best for getting no backlash.